Hello and welcome back to IB Science Mastery, and hopefully today I'm going to be answering some of your questions about relative abundances of isotopes by going over this practice question. So this question looks at calculating the relative abundances of isotopes using a provided data table. So here we have isotopes of lithium. We've got lithium 6 and lithium 7 with their provided atomic masses, and what we're going to be doing is calculating their relative abundances using the average mass as provided in the periodic table. So first we're going to want to start by defining what isotopes are. So isotopes, isotopes are atoms of an element, but they have the same number of protons, which is what constitutes being an element, but they would have different quantities of neutrons, which would give rise to different atomic masses. Next, looking at the question, we're also going to want to define what relative abundances are. And the best way to go about describing what relative abundances are is the percentage abundance of each isotope as found in nature, which then makes up the atomic mass as you would see in the periodic table. So that could just be defined as the percentage abundance in nature. So now we're going to look at solving this question now that we've defined the key terms that are in it. So in order to do so, we're going to set up a little algebraic equation, and we're going to set 6.94 as the subject because that's the atomic mass, and then what we want to solve for is the proportions of lithium 6 and lithium 7 that make up the atomic mass that's given in the periodic table here. So in order to do that, we've got the average mass here, and to make up 100%, we're going to want to have, well, to make up 100% of two isotopes, we're going to have some value x and 100 minus that value, and that is going to add up to 100. So we're going to then assign x to be lithium 6 and 100 minus x to be lithium 7. So now we can set up the equation, and remember these are percentages, so we're going to divide the equation by 100, so 6.94 equals 6.015 x, because 6 is the atomic mass of lithium 6, plus 7.016 times 100 minus x, all of that over 100. Now we can simplify this to cancel out the 100 on the bottom, which is going to multiply the other side by 100, so you've got 694, and then you've got 6.015x plus 7.016 times 100 minus 7.016x, right? And so now you can simply rearrange, and you're going to get negative values, but at the end of the day you can solve it, and your x value, this is a simple algebraic equation, so you'll be able to solve that. Your x should equal 7.6%, and then in that case 100 minus x is going to be 92.4%. So your abundance of lithium 6 is going to be 7.6%, and your abundance of lithium 7 is going to be 92.4%. So hopefully that helps, and thank you for watching.